During class, we've spoken about the idea of vectors as having a bigness, in other words, a length or a magnitude, and a direction, the direction in which they're pointing. So we're going to go through some of those concepts now. I have a vector here in component form. Okay, this is component form with those weird bracket things. And I'll do an example in a minute or two where it's in principal vector form, right, with the I and J principal vectors. We'll get to that one in a bit. First, this one. So here's my vector, u equals bracket -1, comma -5. And we're going to figure out the magnitude of this. Now, if you make a little plot, I find this a nice way to start. If you make a little xy plot and you imagine where your vector is on this thing, I go -1 over and -5 down. So here's my vector right here. This solid red arrow is the vector, and the horizontal and vertical lines are the components of that vector, -1 and -5. So if I want to know the length of the hypotenuse of this triangle, we have a way to do this already using the Pythagorean theorem, if you remember that one. So this formula really will not, I don't think this is going to shock anybody. The length of the hypotenuse is just the square root of the legs of that triangle squared. Okay, so this one turns out to be radical 26. That's quite nice. Now, for the direction of this thing, we can figure that out too, also using what we remember from SOHCAHTOA. If you remember this little angle right here in our discussion of the coordinate plane, I could say an equation like this. I could say the tangent of that little angle, which I'm calling theta u, equals opposite -5 over hypotenuse, -1. So that means theta u equals the arctan, or the inverse tangent of -5 over -1. Okay, now let's bring this down here, because this is going to take a little bit of work. Oh my gosh, I'm gonna have to talk about this just a little bit more. This idea. So that's the arctan of 5, which my calculator says is 1.3734. My calculator is in radians. Now, for an application like this, it's not the greatest unit. There's times when radians are better. There's times when degrees are better. In this case, I would prefer to have it in degrees. 78.7 degrees. Okay. Now, what's wrong with this picture? Think about what 78.7 degrees is telling you. That's telling you we go a little bit around here, but we haven't even left the first quadrant yet, and then we shoot off in this direction. Well, that's completely wrong, right? This direction is 100% opposite from the way we know we're going, and the reason for that comes down to what arctan is in a calculator. Remember, tangents, or arctangents, assume you are in these two quadrants, quadrants 4 and quadrants 1. And a calculator is an idiot, and it doesn't understand the bigger thing going on here of pointing down into quadrant 3. So we have to make a manual adjustment here. We have to say, okay, no calculator. We want another 180 degrees. We're pointing down into the left, not up into the right. So that's going to be equal to 258.7 degrees. You cannot, in this unit, just rely on the calculator to give you the right directions. You got to keep a hand on the wheel here, guys. So that's 258.7 degrees. Now, the unit vector in the direction of u, watch what I'm going to do here. That's talking about, well, I want you to go in the same direction as this vector, but I want you to only go one unit. Okay, like, see this little blue thing I'm drawing here? Here's my unit vector. It's teeny, but it goes in the same direction as the red one. So how do we get a big arrow to become a little arrow? Well, you divide it by something. And the thing we're going to divide it by here is the magnitude. This is like dividing 5 by 5, so you get 1. Well, in this case, I'm going to divide by radical 26. So this one is just going to be, well, you take the same vector that we know from before, -1 and -5, and we're dividing each of those components by the bigness of the vector, which is square root 26, and that's that. Now, in the next example, this is largely the same, except this is principal vector form, which in some ways just makes it easier to work with because we have these principal components I and j. Remember, I is not the imaginary number anymore. I is 1, 0, and j is 0, 1. In other words, the I vector, if you think about it, is just this wee little guy going one unit in the x direction. Okay, that's I. And j is just this other wee little guy going in 1 unit in the y direction. That's all these things are. So the magnitude is going to be easy to figure out. We're going to use the Pythagorean theorem thing again. Square root of, in this case, the legs of the triangle are 5 and -5. Okay, so I put those together and I get the square root of 50, and if you like, you can write that as 5 square root 2. Okay, I'll do that. I'll simplify it and say 5 square root 2. The direction of this thing, remember, we got to be careful with this one. Theta c formula is the arctangent or inverse tangent, whichever one you prefer, of the y direction, which is -5, over the x direction, which is +5. Okay, so the inverse tangent of -1. Well, where's that? If you remember your unit circle, which I always do, I don't forget that, it's very, very useful. The inverse tangent of -1, there are 2 places on my unit circle where -1 happens as a tangent value. Over here and over here. This is a nice special angle, so we don't need a calculator for this. Well, which one of those makes sense? Does it make sense that I am going down and to the right or up and to the left? Okay, for this, we have to look back at the vector. Look what the vector says. 5 to the right, 5 down. So that means this stuff over here is not allowed, and I'm going to be using that idea of going down and to the right. So I'm going to say this equals -45 degrees, or if you prefer, you could say 315 degrees. Kind of depends on what the problem specifies. This problem is going to want you to say it in terms of an angle between 0 and 360 degrees. So I'm going to pick that 315. If you said -45 degrees, you'd probably just confuse the silly computer, even though it's the same exact thing. So I'll edit this to have some more instructions included there. Now, unit vector in the direction of u. Remember, this is very easy. We're just going to take that same original vector we had, which was 5, comma, -5. Oops, hold on. We don't want this in that form. We want it in ij form. So this is going to be 5i and minus 5j. And the difference here is we're going to have to divide this by the magnitude, which is 5 radical 2. Okay. Now, if you want to say it like this and just leave your answer that way, fine. You know, we're big kids now. We don't need to simplify every single fraction. But if you would rather simplify this fraction, that's fine too. You could say 1 over radical 2i minus 1 over radical 2j. These are completely equivalent. And you could even rationalize those. It really doesn't matter.